So during his keynote at last year's NACIS meeting in Tacoma, geologist Nick Zentner discussed Washington's Ice Age floods, which shaped much of my state's topography. One location that he focused on was Dry Falls, which is this iconic geologic site in eastern Washington. And this past year, we at the Washington Geological Survey made an interpretive map of that particular site. So today I'm going to talk about the significance of Dry Falls, why it's an interesting place, and how we created that map. Okay, but first and foremost, I wanted to mention my partner on this project, my colleague, Dr. Joel Gombiner. Joel has spent years studying the Cordilleran ice sheet, and his work has actually been really integral in developing new theories on ice age flood sources in the Pacific Northwest. So he does really great work. And I've been working with him over the past year or so to map and interpret ice age geomorphic features across our state. Okay, so I want you all to think about the largest waterfall that you've ever seen, wherever that is, doesn't matter. Once you have that image in your mind, just pretend that somebody turned off all the water, just turned off the faucet. So that's basically what Dry Falls is. It's this just gargantuan dry cataract that ancient floodwaters flowed over in eastern Washington. And it's on a far larger scale than any of the world's current waterfalls. So during the end of the last ice age, catastrophic floods known as the Missoula floods swept through this region, eroding the cliffs that you see in this photo. In 2023, the significance of this site was recognized by the International Union of Geologic Sciences when it was selected to be one of the first 100 international geological heritage sites. And these were areas that were designated for their significant impact in understanding the Earth and its history. So this is deemed kind of a world-class geologic site. So for cartographic context, here's Washington State showing the ice from the Cordilleran ice sheet at the top there during the last glacial maximum. So about 15,000 years ago, more or less. So during that time period, a lobe of the Cordilleran ice sheet, if you can see that little circle up here, there, it blocked the Clark Fork River near what is near Lake Pend Oreille in what's now modern-day Idaho. So this ice dam created a giant lake known as Glacial Lake Missoula, which you can see in dark blue there. And there's really strong evidence that that ice dam holding back that lake failed repeatedly, releasing periodic glacial outburst floods across the plateau. And you can see all the areas in blue are areas that were likely affected by those floods. So they scoured everything in their paths, carving deep channels in the landscape of eastern Washington. And that area is now known as the channeled Scablands. So here's the location of Dry Falls in orange in the context of the channeled Scablands. And it's actually kind of in the middle of this floodway known as the Grand Coulee, which you might know in the context of the Grand Coulee Dam, but we're gonna zoom in on that and get a little closer look. So the most obvious feature in Grand Coulee is Banks Lake, and it's that vertical reservoir. It's about 27 miles long, and it occupies it occupies Grand Coulee now. It's used for irrigation, but north of Banks Lake near the top, that's where the Grand Coulee Dam is, and that actually blocks part of the Columbia River. So these arrows here, they show where ice age floods sort of surged through that coulee as it flowed south through that channel. And when we zoom into the center of the coulee, you can see the location of Dry Falls. Get a little bit closer here. And this whole eroded area is where the water flowed across. So you see that lighter colored line, that's basically the cliffs of Dry Falls and what's known as the Great Cataract Complex. It's that entire cliff area. So this is actually the view from below that Ice Age waterfall, and it's kind of a classic canyon view. You don't really get a good sense, though, from the ground that this place was created by massive floods or that, they once had water flowing over them. Looks like you might see like Wile E. Coyote running across there or something, but you really need to see this place from above to get a fuller picture of what was possibly going on here. So this is that same area from the sky, and you start to get a sense of how strange and really large these landforms are. So that last photo, if you see that little white arrow on the bottom, that's about where that photo is taken, looking more or less towards the north. So here's that photo again, just a big, big place. This 1935 air photo is from a slightly higher angle, and it shows this region before there was a dam and before the reservoir was there. So if we highlight that, those white lines at the top, that's the Grand Coulee coming down, and then the white lines at the bottom are the cliffs at Dry Falls. And just for scale, you can look just above Coulee City, you can kind of see some little white houses there to give you a sense of the size of this. One more aerial view here. Geologist Bruce Bjornstad's drone photography of Ice Age floods features are some of the most successful depictions of the sort of grand scale of these landforms, including this view of Dry Falls. And you can actually see the Dry Falls Visitor Center, that little white dot in the corner, just to give you an idea. And that's where most people view this site from. This oblique comparison from 1932 is made by J. Harlan Bretz, and Bretz he's the geologist that was credited with first kind of unraveling the mystery of the channeled Scablands and the Missoula floods. And Bretz wanted to compare the large scale of the Great Cataract group, the Great Cataract complex there, with Niagara Falls at the same scale. And this is kind of a little hard to see. There's a lot more lines than there needs to be, so I kind of cleaned it up a little bit. Hopefully that helps. But you can see the two falls at Niagara Falls here in the top corner compared to the same scale of Dry Falls. And if you're not familiar with Niagara Falls, just to remind you, it drains 4 out of the 5 of the Great Lakes. So this is not these aren't small waterfalls. This is a big place. So, but it looks tiny compared to Dry Falls. Geologist and artist D. Molinar painted this Niagara-like depiction of what Dry Falls might have looked like during the last ice age. And you can see the Okanagan lobe of the Cordilleran ice sheet at the top of the image there. As impressive as this image is, though, many, including Nick Zentner, thinks that this vastly underestimates the amount of water that the Missoula floods would have generated. So with that said, we're going to watch this video. I think he had part of this in his keynote speech last year, but there's a really good part in here that I don't think he did have. So I'm going to see if I can hold the volume up to the microphone just so you can hear it. Let's try it.
This is water from a bursting ice dam.
That's not going to work.
70 miles away in
Can you? Okay.
Ripped through central Washington. A wall of water that dwarfed the local landscape with the energy of 10 times the power of all the world's rivers combined.
Here comes the good part. See that little car at the bottom?
An ice age flood with water, rock, soil, and icebergs 3.5 miles wide on a thundering journey to the Pacific Ocean.
So that gives you a little better idea of the amount of water that could have been going over this location. So all these various sort of bird's eye views and aerial depictions inspired us to make a map of this place. And with the ultimate goal of conveying that vast scale of these landforms while also interpreting how these landscapes came to be. So how can we convey that grand scale with a terrain map of this area? Just to start with, this is a view of the Great Cataract Group and a USGS map from the 1950s. And it does a pretty good job of representing all those cliffs. Here's that same view with LiDAR data. And this was actually basically the last place in Washington to have LiDAR data collected. So we've been waiting a really long time. So we were really excited to see it. And it obviously has a lot of great details. But this top-down view doesn't really give you that same impactful presence that an oblique map does. So we lowered the angle and moved around some lighting to try to get a better vantage point that spans that entire width of the floodway there and all of the cliffs of the Great Cataract Group. So I usually start a map like this by making several terrain layers using the same extent and angle, hill shades, slope shades, elevation models, imagery, and I export these all out to Photoshop from a GIS. In this particular instance, I used an application called Quick Terrain Modeler to render these images. It does a really nice job of making really sharp images, but you can basically use any 3D GIS software and use the same sort of methods. So I bring these into Photoshop and then blend them all together, basically. In the end, I basically just used mainly two elements. I used this blended hillshade that I made out of a few different ones, and combined that with this NAPE aerial imagery, which isn't terribly exciting to look at. This is actually just draped over a digital surface model, so there's actually some vegetation and buildings that kind of bump this up a little bit. But I wanted to choose the imagery with the least amount of shadows because I wanted to get rid of them all. And I sent Tom Patterson a message like 1 or 2 years ago, so thanks, Tom, for answering my email, about how to get rid of shadows, and he was very helpful. Fortunately, there aren't that many in this image, so I just basically used the what's the little magic wand tool, thank you, in Photoshop to select them and get rid of them. So here's what that looks like without those shadows. And then we just blend those two together, and it gives you a really nice image. The reason I wanted to get rid of the shadows is because I was using an artificial angle. Basically, this lighting's coming from the north, which never, ever happens, but I thought it did the best job of representing the shadows of those landforms. So after desaturating the colors, adding some haze, and making some more cosmetic adjustments, this was what it actually looked like in the end, kind of toned down a little bit. So we're just going to zoom into part of the image to show some of those changes up close. So this is the blended image before making adjustments. Draped imagery often gets distorted on vertical or near vertical surfaces, but I was really lucky here because these streaks on those cliff faces look almost exactly like vertical columns of basalt, which is what actually is here. So sometimes those things can work out. But basically all I did was add some horizontal layers, some darker layers in between those in the end, which we'll see here in just a second. And the second thing that I didn't like about this a lot is it was very smooth from that LiDAR elevation model. So I wanted to roughen it up a bit. So I went outside, I looked at the sidewalk, I took a photo, and I brought that back into Photoshop. I kind of multiplied it a bunch of times, mosaicked it, and smoothed it together, and just overlaid that over top. Here, I used a layer mode on top of that. Let me tell you what it was. Hold on, I forgot already. I used the overlay layer mode. I just put that right on top of the image, and it worked really well. So let's see what this looks like after changing it, making those changes. So I also desaturated things a little bit, and I feel like that texture gave it a little bit more warmth to the image. All right, so here's that full image again. Of course, we need to add some context to make it a map, so that's where Joel's expertise came into this project. So that's what the map looked like with everything added onto it. So let's take a look at some of the details. To start with, Joel wrote a really great intro text summarizing the story of Ice Age flooding and the current scientific thought around how many of these features were formed. To add some more contextual information about the region, we had 3 sort of supplemental maps that we added to the side. And the first one of those had the widest extent and provided an overview of the Ice Age geography and the Missoula floods in the Pacific Northwest. And then we kind of zoom in a bit to Grand Coulee for a sort of medium regional extent to sort of point out some of the geographical features around there and where Dry Falls is situated within the Grand Coulee. Whoa, I forgot that was in there. All right. And then the third map, since this is an oblique view, scales are a little weird with oblique maps, so this kind of provides a relative scale of the entire map area. And those falls were about 3.5 miles across, so they're quite large. So much of Dry Falls is actually a state park, so we added some select trails as well as the visitor center on the cliff's edge. But our main goal with the map, though, was to interpret the geomorphic features that you can see in the landscape. So you can see some of those short descriptions overlaid on the map here: plunge pools, gravel bars, basalt blocks, just to name a few. And we also added some large arrows to the map to indicate the directional flow of the floodwaters. So let's just look at one of those features really quickly here. This screenshot shows several potholes near Deep Lake on the map, and those are kind of those circular holes that you see near the bottom of the map. And as this states, they were formed from turbulent vortices in the floodwater, and that's kind of like an underwater tornado, basically, that scoured out these large holes in the bedrock. So here's a little schematic that kind of shows how that works. And those underwater tornadoes were called colks, so they basically just ground that out. And you'll see this in modern-day rivers, too, where you have little potholes in the bedrock sometimes. But this is what that looks like. This is a drone shot of one of those potholes. And then this is what that same one looks like from the ground. For scale, here's Joel. So it's a big, big place. And that's a full-size tree growing in it, too. A lot of these are about 50 feet deep, so they're quite large. So you can see that, a visit to this area with this map in tow can really give you a good appreciation for how big this entire landscape is when you compare it to some of the smaller features. Map features like Cooley City and the state highways also add a nice built-in sort of relative scale to the map. You can compare the cliffs to the houses. So here's the final map. I just wanted to add that we had input from many reviewers for this, which helped a lot. Several external Ice Age floods experts, state park interpreters. We also did an interview on Nick Zentner's YouTube channel in order to crowdsource ideas from some of his viewers. He has a very large and very knowledgeable audience, and we actually incorporated several of their ideas into this map ultimately, so that was great. And we also partnered with Washington State Parks on this project, so you now can get prints of this map at the Dry Falls Visitor Center. Okay, so one last slide here to wrap things up. I just wanted to leave you with this time-lapse image sequence taken at Dry Falls by interpretive specialist David McWalter. So as this video progresses, the fog begins to roll over Dry Falls, and it just reminds me of the floods flowing over the cliffs. I thought it was a really evocative way to see this place. So. I think it was early in the morning, but I'm not sure exactly. I think looks like wintertime too. All right, thanks you for sticking around.